Hello students, welcome to the next lecture on the linear algebra. Today we will discuss all those questions related to this December 2018 part B and part C. We are explaining the 10 plus questions related to the linear algebra with the help of shortcut tricks. You can simply follow my YouTube channel Dr. Harish Garg, or else you can simply scan and join my WhatsApp group discussions related to the CSR net. What you will be found on my YouTube channel, you can see the various PYQ questions from the year 2011 to 2023 on the various topics such as partial differential equation, integral equations, calculus of variations, eigenvalue, linear programming problem, optimization, differential equations, statistics. All are available in my playlist CSA net UGC here. You can simply follow and join with my group. So let's start with this video. What is given to you? This is the part B. Only one correct option is there. W1 and W2 are the two subspaces defined by here. W is the subspace of the R cube such that their intersection is my here. There is a span of this, and W intersection this is orthogonal to the pairs of the W intersection here. Then what will be the value of this W? That's very simple. If I simply take W is the element spanned by of this here. These are the combination of the R cube. Clearly says from the first option, the intersection is the span of this. It means this element must be the part of this. Definitely, otherwise the intersection meaning of this. So clearly says that option B, none of them is a part of the 0, 1, 1. So the option B is cancelled out. Similarly, the option 4th is also cancelled out. Fine. Now how you can move from the first and the third? We can use the orthogonal property. So if I say W here, it means that element is the part of this. That element is also the part of this because of the intersection. Now what is the meaning of the orthogonal? That means this pair, the inner product of this with the element of here W intersection W2 is my 0. So what is the meaning of that? Y plus Z is my 0. Now look at the option third. Y, this is my Y, this is my Z, but Y plus Z is non-zero. So this option is cancelled out and this option is correct because this is my Y, this is my Z. Sum of them is a 0, satisfied. Right answer is my E. Look at the another option, another question. So C is my matrix which is related to the basis 1, 2 and 2, 1. Then capital T, we have to define the relative basis. So that's very simple. We can find the firstly here. What is that? It is 3. Then it is minus of 3. And second one is 2, 1. It's a 2 plus 1 is 3. 2 minus 2 is 0. Now there are the two methods how you can find this relative matrix. The first method is you can write this pair as linear combination of this plus beta times of here, and similarly for the 3, 0 as linear combinations of this. Then you can find the value of alpha and beta after solving it. Another way is you can look about the options. What you can do, look at the, if I just take the first option, if I multiply this pair by the first one, that is a 1, 2. It's not a matrix multiply. I multiply this pair by here and then this by this. If I got this pair, then we will get this is the right answer. Look at that, 3 minus 6, it's a minus of 3. And second one is, but we need a plus, first one is a plus 3, but we get as a minus 3. So this option is cancelled out. So 3 and minus 3 pair will be cancelled out. Now if I multiply this pair as the first one, 1, 2, it's my minus 3 plus 6. So it is my plus 3, that's satisfied. Minus 2 plus 2. Minus 2 plus 2, 0. But we need as a minus of 3. But it will give as a 3, 3. So look at the second pair. If I take as a 2, 1, it's a minus 6 plus 3. Minus 6 plus 3. Minus 4 plus 1. So it gives you as minus 3, but we need as a plus 3 and minus 3. So this option is cancelled out. If I look at it here, minus 3 plus 6. Minus 3 plus 6 is plus 3. Minus 1 plus 4 is a minus 1 plus 4 is my here. Similarly for the second, so all the options are here. So this is my correct option in this pair. Look at the next one. So you have to find the dimension of this. That's a very simple. The simplest way you can write in terms of the matrix. The pair of this as U, V, W and X. Now you can write the pairs. This is 1, 1, 1, 0. This is 2, 1. This is 2, 0, 2, minus 1. Now what is the shortcut tricks is, you can firstly you can make them as a 0. This is a 0, you can multiply 2, this is minus of 2, you can multiply 2, this is a 0, this is here. Now you can add them, so you will get as 0, 0, 1, minus 1. Fine. Now look about this value. So diagonal entries is my here, here and here. These are my diagonal entries. Sorry, I can skip, I can write for you again. I think I have misread these values. UVW 1 1 1 0, 2 1 0 and 0, 2 2 0, minus 1. Now you can make them as here. So 1 1 1 0, 0 2 0 1. I can multiply 2 and subtract them, 2 and subtract them, and here. Now you can add them. This will be the 0, this will be the 0, this will be the 0. Fine. So how many diagonal entries are there? This and this. This is corresponding to the V, this is corresponding to the. So how many free variables are there? That is non-diagonals. One is the W, second is the X. So it has the 2 values, so the dimension of W1 is my 2, but here is 1, this is a cancel out. Similarly, we can write for the W2 U, V, W, X according to this. So 1, 1, 1, this is 0. 1, 1, minus 2, 0. Third one is V is 1, minus 1, 0, 0. Now I can write this as, I can simplify minus, it's a 0, 0, 0, minus 3, and it's a 0, 1, 0, minus 1. Fine. Now what you can do, you can interchange them. You can interchange them, otherwise this you can interchange them. So how many are there? Diagonal values be. So 1 0 1 1, 0 1 0 minus 1, 0 0 0 minus 3. So clearly says it has a diagonal value, it has the diagonal, it has the value. So the third component, that is a W, is a free variable. So how many free variables are there? 1. So the dimension of W2 is my 1. So it's a cancel out. Is there any common variable in this? You can see W is my common variable, so there is only one common variable, so the dimension is my 1. So this option is cancel. So the right answer is my C is the correct answer. Okay, now look at this. A is my complex matrix and it's a self-adjoint. That is, A is my A transpose. B is my inverse of this. Fine. Then you have to find the eigenvalues of here. That's a very simple. You have to, it's n cross n. It is nothing is given to you. You can simply take a 2 cross 2. Any of the matrix which satisfies this property. So it's a complex matrix, so simply I can take A as a 0. Then what are the eigenvalues of the A? 0, 0. What are the eigenvalues of the B? Once A has a 0, 0, what is the eigenvalue of the B is iota inverse minus iota inverse. You can substitute here. What is the eigenvalue of A? 0. It's minus iota. It is 1 by iota. This is minus 1. So these are the eigenvalues of this corresponding to the 0. So you can discard the option. It's a purely imaginary, cancel. It's a real, that's my fine. It's modulus 1, that may be good. It's a modular less than 1, that's false option. So out of these two options we can think about the another option. Any of the matrix, which of this, I can simply take A as I. What are the eigenvalues of the I? 1, 1. What are the eigenvalues of the B? It is 1 plus iota inverse. If I substitute here, so what are the eigenvalues of this? 1 minus or 1 plus of this. So what is the meaning of that? Is it a real? No, it's a complex number also. So it's cancel out. So it's a modulus 1 is the right answer of this problem. Okay, U is my orthogonal basis. These are the columns of this. U1, U2 and up to UN are my orthogonal basis. M is a UK, so somewhere is my UK. This is my M. This is my N. Start from here. Then P is my diagonal of the K cross K such that of this. So that's a very fine. Now look at that. M is my orthogonal. So it means the column of the M and N are my linear independent. Fine. Once they are the linear independent, it means the determinant of M matrix is non-zero, determinant of N matrix is non-zero. That's fine. What is the rank of the M? If it is a non-zero, the value of M is my K, so the rank of the M is K, rank of the N is my N minus K. Fine. Now you can think about that. Firstly, you can see about the C option. What is the rank of the M star N? It is always be less than of the rank of the M. M and M star are same because this is the M into M star is I, N into N star is my I. So it's a K and it is N minus K. It's a less than equal to, but they are talking about the equality. This is cancel out. What is the M into M star is I? This is my K cross K. This is my N cross K, N cross K. Then if you add them, this will give you here. What is the size of this? This is my I of N cross N. So what is the rank of this? This is my N, but they are talking about the less than N. So this option is also cancelled out. Look at the first option. Because it's an orthogonal matrix, it's an invertible. So it means M inverse exists. Fine. So whenever M into M star is I, what is the meaning of that? If you multiply, M star is nothing but my M inverse. So I can return here M, P and M inverse. What is that? Because these are the diagonals, these are the orthogonal. So what is the meaning of that? This is nothing but my P because they are my symmetric or they are my orthogonal. So what is the rank of this? So what is that? Now you can find the rank of M, P, M star. That is the rank of the P matrix. But what is the P? P is my diagonal values A1, A2 and AK. So the rank of this is my K, provided each of the AIs are non-zero. But it is nothing mentioned that AIs are my real numbers. So if I suppose AK is my 0, then the rank of this will be less than of the K minus 1. But here is a K. So this option is also cancelled out. What is the trace of this matrix? The trace of this matrix is nothing but my trace of the P. What is the trace of the P? Is the sum of the diagonal entries. So this is the right answer of this problem. Okay, next one is, this is very simple because B of A comma B is my AB. Then which of the following is the linear, positive, definite, bilinear? What is the property of the linear? We all know if you take as this, it will be alpha times of U. So what will happen? Also, you can say this is a degree 2, it's a non-linear. Anyhow, if I take alpha A, alpha B, it is alpha square AB, which is not equal to alpha times AB. So first option is cancelled. What is a bilinear? You can see any of the function is bilinear when you take A, this plus of this. It must be equal to alpha times B of AB and beta times AC. Now you can see the left hand side is alpha AB, right? This is AC. What is the left hand side is alpha times of beta C. So can you say this is equal to this? Can you say this is equal to this? Yes, this is equal to here. But is there any neither the linear nor the bilinear? Okay, any other property? You can see alpha U plus beta V and say is here, which is alpha times of UW and of this. So what is that? On the left hand side is a U of here, right hand side is alpha UW plus beta of, it is also satisfied. It's a bilinear, but they are, it's a bilinear, but it is talking about nor bilinear, so it is a cancel out. Positive definite, symmetric. Firstly we are talking about the symmetric, so it is a symmetric. B of A comma is my BA, which is a symmetric. Positive definite, any of the function is said to be the positive definite bilinear when f of A comma A is my greater than 0. So what is the B of A comma A? B of A comma is A square, which is a greater than 0. So it is a positive definite, but they are talking about the not positive. This option cancel. It's a positive definite, bilinear yes, positive definite yes. Right answer is my B is the correct answer. Okay, next one is T is the linear map which satisfied here. Fine. So you can write the characteristics equation. What is the characteristics polynomial of this? This is my 1. So what is this represent? This represents the determinant of A, which is a non-zero. What is the meaning of that? It's a non-zero, it is a invertible. So once T is my invertible, what is the meaning of that? 0 is not eigenvalue. Fine. If 0 is not eigenvalue, then what is that? T minus ai. T minus I is my t square. It means 0 is not eigenvalue of t square. What is the meaning of that? T square is my invertible. So it means t minus I is invertible, but they are talking about not invertible. This option is cancelled out. Another way is we can find the eigenvalues of this. What are the eigenvalues of this? Omega, omega square. So what is the eigenvalue of t minus I? Omega minus 1, omega square minus 1. Clearly says that omega minus 1, omega square minus 1 is non-zero. So it means this is invertible, but they are talking about not invertible. This option is cancelled out. T has the real eigenvalue. That's wrong because this is a complex number. So it is here. T cube is my minus iota. So what is the meaning of that? That's a very simple, because we all know this is there. If I multiply both sides by lambda plus 1, so what is that? This is a cube plus b cube is 0. What is that? This is minus 1. It means this is satisfied. So the right answer is A and D are the right answers. Okay, now look at this. Is consistent, consistent, inconsistent. Whenever rank of A is rank of the argumentric matrix, and sometimes it is not equal. If it is equal to, then we can say it's a consistent. If it is not equal to, then we can say it's a inconsistent. Fine. Now that's a very simple. We can write corresponding to them here as a B, 5, 1, 1, 4. We need a B2 also. I can write as a 1, 5, 3, 3. I need a B1 minus B2 also. So I can written as 0, 0, minus 2, 1. Fine. Now what you can do, I can make them this as a 0. So 2, 0, 3, 2, 0, minus 2. This is my A. So this is my 0, 0, 1, 0, 0, 1, minus 1, 0, 3, 4, 4, 4. So how you can make them? I can take R4 minus half of R1. So 2 minus 0 is 0. 0 is 1. 1 minus 3 by 2. It's my minus half. 0 is my minus 1. 0 is remain 1. It is half, and plus 1 is 2. Similarly, I can write for here. The first value is my 5, 1, 1. If I multiply 4 minus 5 by 2, 8 minus 5, 3 by 2. Similarly, for the second pair, 5, 1, 3. So it's a 3 minus 5 by 2. It's my 1 over 2. For the last pair, it's my remains same. Now I can subtract them. R4 minus R2. So this value will be my 0. This is same. This is my 0. This is my minus of 2. This is my minus of 2. This value will be my plus 1 by 2. This value will be my minus 1 by 2. This value will be my minus 1. Now I can make this number as a 0. I can multiply this number by half and add them. 0, 0, 0, 0, 0. Half, add them 1. Half, add them 1. Plus 1, half, add them 0. Fine. So what is the rank of the A? This matrix is my A, 3. Rank of A condition B. The first one is corresponding to the B1. Second one is B2. Third one is B1 minus B2. Now it clearly says that it is my 4 for B1 and B2. It is 3 for B1 minus B2 because of this 0. So what is the meaning of that? Both the ranks are not same. It means this is inconsistent for the B1 and B2. First option correct, second option cancel out. It has the same rank as of the A. B1 minus B2 is my consistent. This is my consistent. So the right answer is my A and C are the correct options. Okay, now look at the another one. So this is question number 65. It is a 3 cross 3. It has 3 eigenvalues. One eigenvalue is given to view 1. Definitely other eigenvalue is my minus 4. One of the eigenvalues is minus 4 because it is a minimal polynomial. Minimal polynomial has the root of eigenvalue. How you can find the third eigenvalue? Because the sum of the diagonals is my eigenvalue, so it is my 1. So it means eigenvalues are my 1, 1 and 4. Firstly, we will check whether it's diagonal or not. Algebraic multiplicity of the 1 is my 2. We can find the geometric multiplicity of 1, that is a 3, number of the rows, minus rank of a minus 1i. So what is the a minus I? You can see 0, minus 1, 1, 2, 0, 4, minus 2, 0, minus 4. Clearly say that if you add them, it will be my 0, 0, 0. Rank is my 2. So it is 3 minus 2, 1, which is not equal to the algebraic multiplicity. So M is not diagonal, that's a correct statement. Fine. Now look at this one. If x minus 1 and x plus 4 is my minimal polynomial. So remember, this is the one tips for you, or you can say the remark. M is diagonal if and only if the minimal polynomial of this matrix has no repeated linear factor. That's a simple rule, has no repeated linear factor. If this is the minimal polynomial, what are the roots of this? 1 and minus 4. It means this is a no repeated and it is also linear. So what is the meaning of that? It means the matrix M is diagonal, but we already proved that the matrix is not diagonal. So this option is cancelled out. So the right option is my here, because the minimal polynomial is either x minus 1 x plus 4 or either x minus 1 whole square x minus 4, but this is not the correct answer, so that's why. Now so the minimal polynomial is my x minus 1 whole square x plus 4. What is the degree of this polynomial? Degree of the minimal polynomial is my 3, but here what is the degree of this? If I write here 1 by m, because none of the eigenvalues is 0, so it is a inverse is existing. So if I multiply them, m square plus 3m minus of 4i is 0. Its degree is my 2, but we need at least of the degree 3, otherwise the minimal polynomial does not divide this. So this option is also cancelled out. So the right answer is my B and C. Make sure, student, there is a one remark for you here. You can see this is my m inverse. If you think about this value is satisfied, you can see the first eigenvalue 1 is satisfied, 1 by 4 is 1 plus 3 satisfied, minus 1 by 4 is 1 by 4, minus 1 minus 4 plus 3 is also satisfied, but the degree is my 2, which is less than of the minimal polynomial. That's why this option is cancelled. Okay, look at the another one. So A has the characteristics polynomial x minus 1 cube. It means eigenvalues are my 1, 1, 1. A is necessary diagonal. That's a wrong option. There are so many questions are there. If I look about this is the here, clearly say that eigenvalue is this. What is that? Algebraic multiplicity of the 1 is 3. If I found the geometric multiplicity of 1, number of the 3 minus rank of a minus I. So what is the rank of the a minus I? 0, 0, 0. So clearly say that rank is my 1. So 3 minus 1 is my 2, which is not equal to 3. So it is not a diagonal. So the first option is cancelled. Similarly, if this is my option, if m minus 1 cube, what is the meaning of that? It has a, what is the meaning of that? It has a repeated roots. So but already if it has a repeated root, what is the meaning of that? Is it a diagonal? No, because if this is the minimal polynomial, it has a repeated root, but as per the remark we described here, m of a has no repeated linear factor, but then m is only diagonal, but it is here, so this option is cancelled. Third option is a square. So eigenvalue of the a is my 1, 1, 1. What are the eigenvalue of the a square? It is also 1, 1, 1. So the characteristics polynomial corresponding to this is my x minus 1 cube is the right answer. Now we have to define the Jordan block. How you can write the Jordan block? I can simply write here. A has eigenvalue 1, 1, 1. So Jordan block has diagonal entries. So this is my Jordan block. So I can return here, this is the 1 cross 1 block and rest are here, or I can return 1 as a here. So these are my 2 Jordan blocks. So this option is satisfied. Then a minus I whole square is diagonal. So what is the a minus I? If I take, this is my a, so 0 0 0 1 0 0 0 0 0. Fine. So what is the a minus I of whole square? Clearly say that this is 0. So what is the meaning of that? Right hand side is my 0 matrix. Fine. And we all know 0 matrix is my diagonal. So once it is a diagonal, so left hand side is also diagonal. So this is the right answer. So the C and D are my correct options. Okay, look at this one. It's a vector space. It's a linear map of polynomial of degree at most 3. Okay, that's a very simple. Again, you have to construct a polynomial of here. These are my bases. Look at that first one. If I just simply take p of x is my 1, what is that? This is 1, this is 1 2, that's a constant is my 2, rest are my 0. If I take the second pair, that's a x, so what is that? This is my x plus 1 and another one is x minus 1, so that's my 2x. The coefficient of the x is my 2, rest all are my 0. If I take x square, so it is my x plus 1 square and x minus 1 square. If you open them, it's a 2x square plus of 2, so constant is 2, x square is my 2, it is 0. Third one is x cube, so if I take p of x is my x cube, so x plus 1 cube, x minus 1 cube, so it is my 2x cube. A cube plus b cube will be cancelled out, 3a square b will be cancelled out, 3 plus 3 is 6, a square b. So constant is 0, this is 6, this is 0, this is my 2, this is my t. Now look at the first option, determinant of t. Clearly say that are diagonal values. This is my determinant 16, which is a non-zero. That's the correct option. Now fourth option is also correct. 2 is the eigenvalue with algebraic multiplicity 4. Fine. Now t minus of 2i. So what is that? You can find of t minus 2i 0 0 0 0 0 0 0 2 0 0 0 0 6 0 0. Fine. Now that's our very simple, right? Rank of the t minus of this is my 2. Now if I found t minus of 2i square, which is a 0, if you multiply them, clearly say that these two values are there, rest of them are 0, so t of is 0, but it is said it's a non-zero, cancel out. Once it's a square is 0, then definitely cube is also be a 0, but it's a non-zero. So this option is also cancelled out. So the right answers are A and D are the right answers. Okay, now look at that. M is my n cross n Hermitian matrix. Rank is my m. So since n is not given to you, so I can simply take n is my 2 cross 2. Rank of the m is my k, but k is not equal to 2. So it means the rank must be 1. So I can simply take any of the matrix which is a Hermitian. So that is of here. So 1 0 0 0. Fine. So the rank of this is my 1. So this is my key. Then we have to find this value. So okay, lambda is a non-zero eigenvalue. So what are the eigenvalues of this? 1 and 0. So it means lambda is a non-zero eigenvalue is 1. The corresponding eigenvector is my u. This is my eigenvector corresponding to this. Okay, fine. Then you have to find this one. So that's very simple. We can start from here. Fine. What is the m? 1 0 0 0. Lambda is my 1. U is my here. U star is my orthogonal. Because it's a Hermitian, I can written here. So this is 1 0 0 0. If you multiply them, 1 0 0 0. So this is the same 0. So what is the rank of m minus u star? Again it's a 0 because the rank of this is my 0. So how you can relate them with k? If I k is a 0, if it is k1, k is my 1, it's a 2. So the rank is my 0. These options are cancelled. Now how you can prove that? You can simply take as induction, because n I can take as a 2. So I can start from the left hand side. M u star. So if I open this m square minus lambda is outside a real number u star, lambda is outside m u star because it's it's a Hermitian, lambda square u star of square. Now m of u is my lambda of u, so this is my lambda of u, so I can simply say lambda square u star. This is again this, I can simply say it's a lambda u, it's a lambda of u star. So this is cancelled out. This option is the satisfied of this. So the right answer is A and D are the correct options. Okay, now look at these options. B is given to you as of x1 y1, x1 y2, x2 y1, 4 times x2 y2. You have to define W, V belongs to the R2 such that the pair of this will become 0. That's very simple. It means the first pair will treat it as a V0. V0 is given as a 1, 0. Fine. This is my U. It means x1 is my 1, x2 is my 0. So x2 is my 0. This option is cancelled. This option is there. So what is that? What is the value of this? x1 is my 1. This is my 1. So if I consider this V as my say x, y of this, if I substitute here 1, x minus 1, y is my 0. So what is that? This is a pair is x, y such that x minus y is equal to 0. So clearly says that now it is not a subspace. That's wrong. It passes through the origin. It's a linear, all properties satisfied, is equal to 0, 0. That's not satisfied because x is equal to y. It means this is a pair of x, x, 0, 0, 1, 1, 2, 2 and all satisfied. Is the y-axis, that's cancel out y-axis only when x is my 0, but it is not true. Line passing, so the 0, 0, 1, 1 is the right answer. So the right answer is only my D. Okay, look at the last question. So which is the quadratic form and which of the following statement is my equivalent? Okay. A and B are said to be equivalent when number 1, rank of the A, rank of the B are same. Second property is signature of the A, signature of the B are same. Now you all know how you find the rank. What is the signature? That is the number of positive eigenvalues minus number of negative eigenvalues. That's the option. Now we can start from the Q1. We can write the Q1, Q2, Q3 in terms of the matrix because it's a quadratic form. We can easily write in terms of the matrix. Let's start from here. Coefficient of the x square, coefficient of the y square. X, y here we can half them. 3 by 2, 3 by 2. For the second 1, 1. Half them 1, 1. There is no x square, there is no y square, half and half. Fine. Now what is the rank of the Q1? Q1 is 2. Rank of the Q2 clearly says 1. Rank of the Q3 is my 2. Now from here they are not same. The first property not satisfied, it means they are not equivalent. Q1 and Q2 are not equivalent. Similarly Q3 and Q2 are also not equivalent. All are equivalent because the third and first property cancel out. All are equivalent is cancel out. So only one correct option is the right answer. But we can also verify the eigenvalue. So what is the eigenvalue of the Q1? We can write this lambda square minus 1 by 4 is 0. So what is that? It is plus 1 by 2 minus 1 by 2. How many? What is the signature of this? How many positive eigenvalue? 1. How many negative eigenvalue? 1. So 1 minus 1 is 0. We can find the eigenvalues of this lambda square. This is 0. Lambda square plus of 2 and 0. So eigenvalues are 0 and minus 2. It's again 1, 1. So it's a 0. What is the eigenvalue of this? Minus of 3. So 2 minus 9 by 4 is my here. So the eigenvalues are my 3 plus minus 9 plus 1 over 2. So the eigenvalues are plus and this is minus. Clearly say that this number is my negative. This number is my positive. So one eigenvalue positive, one eigenvalue negative. So signature is my again 0. So you can see both the signatures are same, rank are same, so that's why the right answer is my B is the correct option. So this is the way you can solve all those questions in a very simple and the simplified manner. I hope you can learn the concepts. We will see the next lectures on the June 2018 questions as well as the 19 and more. You can simply like, share and comment on my videos. Best of luck students. Happy learning.